Hi folks, welcome to 8.5 polar form of complex numbers, and we are in the third video. And in this video, we're going to talk about products and quotients of complex numbers in polar form. So we're just going to jump right into some examples and see if we can figure out the pattern and the formula that goes along with it, okay? All right, so let's take a look at example 9. We have two polar coordinates, or two complex coordinates in polar form. We have the first one that is Z1, and then we have a second one that is Z2, okay? And that's a common way in which we sort of show that we have two different ones. We call it Z1, Z2, all the way up until Z however many we have, okay? But if we wanted to find the product of Z1 and Z2, all right, what that means is we're taking Z1 times Z2, okay? Now, here's what we're not gonna do. We're not gonna take the R's and multiply them and then take the angles and multiply them, okay? That's almost what we do. It turns out that if we wanted to find the product of Z1 and Z2, we actually multiply the R's, okay? So that would look like, let me write out the whole thing first. Cis 90 degrees times 2 cis 60 degrees, okay? So here's my Z1, here's my Z2, all right? But if I wanted to multiply them, I would actually grab the R's and multiply them. So I would get 2 root 2. But then I'm going to tell you that the new theta is not 90 times 60, but it's actually 150 degrees. Give you a moment to think about where that might come from. Where might we get the 150 degrees from? Okay. And while you're thinking about that, let's go ahead and set up for a quotient. All right, so quotient means that we are going to divide them, all right? So if we were going to find Z1 divided by Z2, we would have root 2 cis 90 degrees divided by 2 cis 60 degrees, right? Here's our Z2. Here's our Z1. And the way we would simplify this is we would get root 2 over 2. So we would divide these two, but we don't get cis of 90 divided by 60. We actually get cis of 30 degrees. Okay. And now with these two side by side, let's think about how we're getting the angles, because it seems like the R's, we just do what we're going to do. We multiply or we divide. How do we get the thetas? Okay. And so hopefully what you may have noticed is that 150 is actually 90 plus 60 gives you 150. And then if we sort of compare that to what we did over here, where do we get the 30? 90 minus 60 gives us 30, okay? So let's try another example and then see if, again, we can come up with this pattern, okay? So we're going to find the product. And we're going to find the quotient. So product, I have Z1 times Z2, which is 5 root 2 cis pi times root 2 cis 2 pi over 3. And I remember from the previous example that I took the R's and I multiplied them. So 5 root 2 times root 2. cis, I'm not going to multiply these. But I wonder if I should add them. Okay, and that's precisely what we end up doing. We're going to have cis of pi plus 2 pi over 3. Okay, now there's a little bit of arithmetic in here, so I want to make sure that we're clear on where we get these from. But root 2 times root 2 is just 2. And then 2 times 5 gives us 10. Okay, cis, in order to add these fractions here, I need a common denominator, right? So really that's 3 pi over 3 plus 2 pi over 3, which gives me, let me shrink this just a little bit, which really gives me 10 cis of 5 pi over 3. Okay, so I'm multiplying my r's, but I'm adding my angles. All right, let's see our quotient. Okay, so again, let's say z1 over z2 will get 5 root 2 cis pi over root 2 cis 2 pi over 3. And if we compare this to the example that we did before, we're going to divide our coefficients, our r's, but then we're going to subtract our angles. We're not dividing the angles, okay? So let's see what we get. We get 5 root 2 over root 2 cis. I'm going to go ahead and write this as 3 pi over 3 because I already know that when I'm subtracting fractions, I'm going to need a common denominator, right? But this 3 pi over 3 is really the same thing as saying pi. All right, let's do our arithmetic. 5 cis pi over 3. And there we have our quotient. Okay, so we're multiplying the r's, but we are adding or subtracting the angles depending on whether we're doing product or quotient. All right. All right. I'm going to leave you to do this last example. I think it's good practice, okay? But let's go ahead and write down the formulas that we have here, all right? So for product, oh man. All right, we're back. For product, we have the following formula. If we have z1 times z2, we're going to have r1 cis theta 1 times r2 cis theta 2. And the way that we put that into, combine those is actually going to be r1, r2 cis of theta 1 plus theta 2. So we're adding those theta. Okay. But if we have quotient, we're dividing them. Whichever one is on top is actually important, okay? But that would be, in this case, r1 cis theta 1 over r2 cis theta 2. And I would get the r's as r1 over r2 cis of not theta 1 divided by theta 2, but theta 1 minus theta 2, okay? So let's get this all on one page for us. We've got it nicely laid out what our product and our quotients look like, but at the very bottom, not only do we have an extra example, but we also have the formulas for us to use, okay? All right, so my friends, that's it for this video. In the next video, we're going to talk about powers and roots of complex numbers. See you there.